our pharmacy. So chemistry plays a crucial role, and at the same time, chemistry is also useful in various sectors for the drug development and discovery. So that is the reason why chemistry plays a crucial role in our pharmacy. So generally, chemistry. So generally, chemistry. So chemistry. So chemistry includes different branches. First branch is organic chemistry, and second branch is inorganic chemistry. Third branch is biochemistry, biochemistry. Fourth branch is pharmaceutical analytical chemistry, pharmaceutical pharmaceutical analytical chemistry, analytical chemistry, and pharmacognosy and phytochemistry, pharmacognosy, pharmacognosy, and phytochemistry. So it includes natural product chemistry. All these things will be included in this one. And regarding pharmaceutical analytical chemistry, this is an analysis subject, and this is an analysis subject. So why we are discussing all these subjects means it is a branch of chemistry. So based upon the subject, different type of specifications will be there. For regarding anorganic chemistry, we are studying what is meant by a reaction, and regarding how it will synthesize or prepared, and what are the uses regarding a definite structure or a compound, and what type of reactions will the compound will takes place, and all these reactions, and regarding that, all this will be studied in the organic chemistry. Coming to inorganic chemistry, various type of impurities. So that during a chemical reaction, inorganic reagents will be used, so impurity. So all this will be studied as per monograph IP. So all this will be studied in inorganic chemistry, and inorganic chemistry also includes inorganic drugs that we are using in different categories, like radioactive substances, okay, and as well as anti-acid preparations, emetics, antiemetics, expectorants, so laxatives. All these different kinds of inorganic drug preparations will be included in inorganic chemistry. Coming to biochemistry, from in biochemistry, from cell to analytical determination of foreign material in our blood will be determined in this biochemistry from different type of chapters. And at the same time, pharmacognosy and phytochemistry, it includes regarding a drug and drug synonym, as well as history, location, collection and cultivation, morphological structures, regarding chemical constituents, and regarding chemical constituents, identification test, uses, adulteration. So all this will be studied in pharmacognosy and phytochemistry. So regarding pharmaceutical analytical chemistry, which includes the quality of a drug molecule, as well as purity of the drug molecule, as well as identity of the drug molecule, as well as strength of the drug molecule, will be studied in pharmaceutical analytical chemistry. So all these are the different branches of chemistry that are involved in our pharmacy field. So today lecture session, I would like to discuss what is meant by a reaction. So what is meant by a reaction? So before we are going to a reaction, what is a drug molecule? So generally in our pharmacy, we are always from we are go to different type of branches like pharmacology, pharmacognosy. So whatever the subject we are taking, it means that includes majority we are discussing on drug. So what is meant by a drug? So drug which is used for the treatment, which is used for the treatment, and drug which is used for the cure, and drug which is used for prophylaxis treatment, prophylaxis, or prevention, and which is also used for diagnosis of disease or disorder in our body. So generally we are using a drug. So drug is nothing but API, API, active pharmaceutical ingredient, which is having a specific therapeutic activity or pharmacological activity. So we are termed it as a pharmacophore, which is having a specific biological or therapeutic activity. So based on this, the drug will be categorized into different type of drug classification or drug classification sectors. Okay, so each and every category of drug is having a adverse effects as well as a beneficial effects. So if we are using drug means, if we are using or consuming drug means, so what is the condition? So what is the condition? So condition. So all the drugs is having both adverse effects as well as beneficial effects. So if we are using drug mean, what is the condition? Beneficial effects is more than adverse effects for the drug, then only we are using the drug. So this is the condition. So if the drug is having more beneficial effects when compared to adverse effects, then only we are using or administering this drug into the patient body. If this condition will not obeys, then we are not obtained or we are not using that drug to the patient. So this is the condition, right? So regarding the drug molecule, for example, if we take aspirin, if we take aspirin, so aspirin is an acetyl salicylic acid. So aspirin is what? Acetyl salicylic acetyl salicylic acid. So acetyl salicylic acid means this is a benzene moiety, and this is a carboxylic group, and this is an acetyl moiety, right? So for this is an aspirin, so which is an active pharmaceutical ingredient or pharmacophore, which is mainly used in the category of drugs like NSAIDs, non-steroidal anti-inflammatory drugs. Okay, so which is an COX inhibitor, right? So this is the category of drugs. So how we will prepare this active pharmaceutical ingredient aspirin? So aspirin, so what is the precursor molecule? How we will get this molecule after synthesizing? So after synthesizing, we are get this molecule. So before synthesizing means what is the steps we are taken to create this molecule or to create or to synthesize these molecules means. So we are prepared for a reaction, or we have to put a synthesis, or we have to keep a reaction in the laboratory, chemical laboratory. So for that, so for that for that, so what we require, so we have to keep a reaction in the laboratory. So for that we required a substrate molecule, and we required a reagent. So this is a gives rise to arrow, then it will forms intermediates plus products plus by products. So substrate will be also called as an initial starting material, initial starting material, or precursor molecule, or precursor molecule. So reagent, again reagent will be categorized into two types of reagent: electron rich reagent as well as electron deficient reagent. So electron rich reagents will be categorized as a nucleophiles and will which is having a negative charge. So electron deficient reagent will be categorized as an electrophiles. So electrophiles is having which charge? So which is having positive charge. In chemistry, positive charge means which is having a deficient, right? So intermediates, generally these intermediates will be formed only in an organic reaction only. These intermediates will not formed during an inorganic drug preparation, because intermediates takes place, or intermediate formation will be takes place in organic reaction only. So okay, what is the property regarding these intermediates? So what kind of properties will having these intermediates? So intermediates are highly highly energetic species. So why it is a highly energetic species? Because these are charged. So these are charged. These are charged ones. So charged ones. So 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 what is the relation means? If this intermediates is having high energy, means which is having high reaction or high reactivity ability, so energy of the intermediate will be directly proportional to reactivity of that reaction. Okay, so at the same time, so stability of the intermediate, so stability of the intermediate, so if the intermediate is more stable, then it will be less reactive. So it means more stable, it is less reactivity. So coming to third relationship, if the intermediate is having more energy, it will be less stable. So energy is inversely proportional to stability. If it is more stable means it is having, if it is having more stable means it is having a less energy. If it is having more energy means, so it is having highly reactive and it is less stable. So these are the relationships before we are discussing with this intermediate properties. So coming to intermediates, so coming to intermediates, so intermediates will be categorized into intermediates. So intermediates will be categorized into two types. First one is electron rich intermediates as well as electron deficient intermediates. Electron rich intermediates will include carboanions. Electron deficient intermediates, which includes carbocations, free radicals, all these are okay, and as well as nitrines and benzenes. So this. So these are the information regarding reaction intermediates. So reaction intermediates in the reaction will be generally represented in square brackets, and the square bracket which is also represented for concentration term. So the units for concentration is mole per liter. So both the concentration terms as well as reaction intermediates will be represented with this square brackets only. And at the same time, in this reaction, products as well as byproducts will be also formed. So substrate and reagents will be present at left side, and reaction intermediates, products and byproducts will be present over left side. So this is a gives rise to arrow. This will separates both left side molecules as well as a right side molecules. That means it will separate both reactant molecule as well as a product molecule. So this is the gives rise to arrow, and this will be also treated as a forward direction arrow. So in this arrow we will represent reaction conditions. So reaction, so conditions. So what is meant by reaction conditions? So what is meant by reaction conditions? So reaction conditions. So reaction conditions. So reaction conditions includes, reaction conditions includes if we using catalyst means, so name of the catalyst will be used in that reaction. So and at the same time, whatever the temperature we are using, so whatever the pressure conditions we are maintained during the reaction was takes place, all these reaction conditions will be denoted or represented in the gives rise to arrow only. Okay, so this is, so what is meant by a catalyst? So generally catalyst, so catalyst which is a chemical substances which are used in the chemical reaction which are in very less quantity. So catalyst we are used in very less quantity, that means in micro quantity, micro quantity. So micro quantity. So second thing, so catalyst will increases, catalyst will increases rate of forward reaction, rate of forward reaction and rate of backward reaction, which increases rate of forward reaction and rate of backward reaction, but does not does not alter the position of equilibrium. So this is the property of the catalyst. So next, catalyst will reduce the EA, means activation energy. So catalyst will reduces the activation energy of the reaction, which increase the rate of forward reaction and rate of backward direction, but does not alter the position of equilibrium. So, and which is the reaction? In this reaction, catalyst, if we are using catalyst, mean the used catalyst in the form of micro quantity. And at the same time, and the last property is catalyst does not involved in the reaction. So it does not, so it does not consumed, sorry, it does not consumed in the reaction. So after completion of the reaction, whatever the micro quantity we are using, so finally that micro quantity of catalyst will be remain as same in the final reaction only after we are getting the product. Okay, so these are the different type of properties we are using if we are using catalyst in the reaction. These are the properties. So these all are the reaction conditions and reaction intermediates. So all these will be very needed during a reaction was takes place, or when we are keeping a reaction in the laboratory. So we have to know all these things while we are going to perform a reaction in the laboratory. So this is regarding how we will keep a reaction